Hi, welcome back. Today is going to be our first coding session, and in this session we're going to build a binary classifier using the k-nearest neighbors algorithm. K-nearest neighbors can also be used for regression, but we will not go into this. Okay, the interface, the programming interface will be Colab. Colaboratory is a Google product and it's cloud-based. The nice thing is you don't need to do anything in terms of downloading software. Yeah? You can just start. It's a Jupyter style interface for those who know Jupyter. And important is that Colab understands Python, Keras and Pandas. These are the three languages that we will use in this course. Of course, Python is the general language. Keras will be used for deep learning and is basically a high-profile API of Google's TensorFlow. And Pandas we will use for pre-processing. Actually, in this exercise, we will already be using Pandas. Just wanted to stress, this is not a coding class. Yeah, I would suggest, if you don't have any experience with coding, to take a few lectures on YouTube. You should know what object-oriented programming is. You should know what a list is or a dictionary. The typical vocabulary of coding you should actually know. But again, I will explain line by line. And even if you don't study the coding behind it, you'll be able at the end of this class to write your programs, because it's mainly the same syntax coming back all over again. Okay, now let's take a look at the example. The data set we're going to use is the Pima Indians Diabetes dataset, and you can find this dataset on Kaggle. Yeah. You should get a Kaggle account because we will be using a lot of Kaggle datasets. And by the way, in order to use Colab, you need a Google account. Yeah? So please open a Kaggle account and a Google account. It's a binary classifier where the outcome is diabetes, y is 0, or no diabetes, and in this case y is 1. Yeah. The data set is basically a table where on top you have all the features, and in this case we will have 8 features. We will have the label in the last column, and we will have 768 samples. Yeah? What is this data set? Basically it's a women only data set, and what happened was that these Indians, they were pretty healthy a few decades ago, but they started eating more carbs, more processed food, and exercising less. And the prevalence of type 2 diabetes is really high. So what we want to check is that can we, based on given features, 8 features, such as the number of pregnancies, glucose, the BMI, predict if a woman has diabetes or not. Okay. Here are the 8 features again. This is the formula for multivariate regression, yeah, but we can still use it for classification. We have normally W0 times X0, but we've seen that we put X0 equal to 1, and then W1 X1 until W8 X8. And this we wrote in a matrix form. Alright. Here I'm giving you a little bit of the sequence of what we're gonna do. We're gonna log into our Google account, and we will log in as well in our Kaggle account. We will look for the dataset, and we will download it from Kaggle. Okay. Then we're gonna store the dataset into Google Drive, and we're gonna mount Google Drive in Colab. This is a routine that we will do all the time, also for future coding exercises. Then we're gonna load the data and create a pandas data frame. This is a CSV file, and CSVs we prefer to pre-process with pandas. A data frame is nothing more than a table with rows and columns. Yeah, nothing more than that. And the data frame will allow us to do certain actions on the data. Then we're gonna look at the data and do some checks. First thing we're gonna check is if the data is balanced. Balanced means out of the 768 samples are half diabetes and the other half no diabetes, or is there an imbalance? This we need to check. We also are gonna check for missing values. Yeah, I already checked these data sets. There's no such a thing as missing values, but we will see that there are some zeros which can be assumed to be missing values. So we will deal with missing values. Then we're gonna pre-process these data. We're gonna deal with the missing values, and we're also gonna do feature scaling. Remember, it's important that in terms of scale, the features have a similar scale, especially for k-nearest neighbors, because the metric we use is distance. So it's very important that we scale the features. Then we're gonna choose k. I explained that for k-nearest neighbors, k is a hyperparameter that you as a data scientist must choose. If k is too small, you risk to be subjected to noise. If k is too large, you risk to take points of the other class. Yeah. Then we're gonna run the algorithm, and you can see before we can run the algorithm, there's a lot to do, and this is typical for machine learning and AI. And at the end, we will evaluate the algorithm in terms of performance. So here we're gonna look back at the KPIs that we saw in the previous session, like ROC, AUC, F1 score, accuracy, recall, all these things we will use here. One last thing. We've not seen this, but after training your model, what we will do is test the model. And testing happens on unseen data. Yeah? So what we're gonna do is we're gonna split the 768 samples into a test set and a training set. Okay, we'll use 20% here. 20% will be a test set and 80% will be a training set. Yeah. Okay, let's get down to the coding exercise.